Okay, this is the review for, or the final review for Unit 2. And the last thing that we added to our list of what we were learning about was composition of functions and function operations. Let's start with composition of functions, putting a function within a function. So let's start by defining some functions, and maybe we'll do some operations with this too. So let's have f of x be the square root of x minus 3. Let's have g of x be 1 over x, maybe, and h of x, let's see, what will I have h of x be? Maybe the square root of x plus 8. Okay. All right. So first thing, again, let's do with compositions of functions first. So one way, and just a little bit on notation, say I asked you to find, let me see which I want to do. Yeah, let's do, say I wanted to work with g of h of x. Just another way of sometimes that this is composition of functions is denoted in, I don't like this way you're going to find, but it's important to show you this way, is with this little symbol between. It just means the same thing. And honestly, if I see this here, I generally just change it to write g of h of x. I just much prefer writing it this way. All right, so say the first question here is find g of h of negative 4. Okay, so to do this negative 4 first has to go through this inner function. So it's going through the h function first. So I'm putting it in for x into h. So I'm putting in negative 4 plus 8. So, and negative 4 plus 8 is 4. So I'm doing the square root of 4, which is 2. So this is really now coming down to finding g of 2, because h of negative 4 ended up being 2. And now g of 2, I put 2 in for x in the g function, and I get a half. So that's just evaluating a composition at a given particular x value. Well, what about if I then said find what g of h of x is and find its domain? Okay, so here's how I go about this, because this is helpful in finding the domain. So I'm putting into the g function h of x, which is the square root of x plus 8. So I write it like this at first, because this is telling me, remember with a composition, it goes through the inner function first. So when we're talking about domain, the domain of that inner function is going to matter, because again, it has to pass through it first. So I'm going to say to myself, okay, I know right away that x plus 8 has to be greater than or equal to 0, or x is greater than or equal to negative 8. So I'm going to keep that in mind when I'm doing my composition here. Okay, so now this means wherever there's an x in the g function, I'm putting the square root of x plus 8. So I go to my g function, and there's just one x here. So square root of x plus 8. And now to complete my domain, not only was I taking into account the domain of the inner functions, but I also now have to look at the end result. And I notice in this end result that the square root of x plus h is in the denominator, so I can't have x equal negative 8. So my overall domain here will be negative 8 to infinity, exclusive of negative 8, because that's where the denominator would be 0. So again, when you're thinking about the domain of composition of functions, it's really the domain of that inner function, because it has to pass through that first, and the end result that you have to keep in mind. Let's do, and we're going to do another composition in a minute, but let's do a function operation. So let's say I said find f plus g. No, let's not do f plus g. Let's do f plus h. Oops. Of x and its domain. And remember, f plus h of x is just f of x plus h of x. So my f function, so f plus h of x is going to equal f of x, which is the square root of x minus 3, plus my h of x, which is the square root of x plus 8. Okay, and the domain. Well, the domain of f was just x is greater than or equal to 3. Can't take the square root of a negative. And the domain of h is x is greater than or equal to negative 8. But if I need my new function, it has to meet both these conditions. So I'm really looking at the overlap between the two. And when I do that, I realize, okay, the overlap here is, because it has to meet both, would be 3. 3 to infinity. So my domain here would be 3 to infinity. And say I then went further and said, find the range for this piece. Well, because I'm putting in only 3 to infinity, I know this piece, the low will be 0. But this piece here, my low will not be 0. In fact, the lowest the lowest output here will, when I put in 3, will be square root of 11. So my range here is not 0 to infinity. It's the square root of 11 to infinity. All right, let's continue with this here. Maybe I'll move it to the side like this so we can still see the original functions. So I'm on 4. What if I asked you to find f of g of x and its domain? Okay, let's go through the same process. So into the f function, I'm putting 1 over x. So right away, I'm telling myself x cannot be 0. It's passing through that inner function, can't be 0. Okay, and wherever there's an x, I'm putting 1 over x for my f function. All right, so now I've got something under a square root, and I know for my domain, under a square root, I need greater than or equal to 0. Well, this brings us back to Unit 1, where I'm solving an inequality. It's not linear. I've got an x and a denominator, so I'm going to make a single fraction, which will have a denominator of x in this case. So I'll have 1 minus 3x over x greater than or equal to 0. And let's do some sign analysis here. So denominator is 0 at 0. And you can't divide by 0. And the numerator is 0 at 1/3. And it can equal 0 here. So if I put in something greater than 1/3, I am like 1, for example, I'm going to get negative. But if I put in something, it should alternate. If I put in something between 1 and 1/3, like a 6, it's going to be positive. If I put in something negative here, this will result in negative. So my domain, again, I'm taking into account here, x cannot be 0. That actually happened to come into play with my inequality inside the square root anyway. So my domain here would be 0 to 1/3 inclusive. So that's getting a little bit more complicated because actually meeting the condition that under a square root had to be greater than or equal to 0 was a throwback to our inequalities from the last unit. So it's important not to forget that stuff, right? And the last thing that I talked about, that was covered in this last unit, which I don't want people to get too hung up on, and it was just a matter of algebra, but I know it was confusing for people, just the notation of it all, is this difference quotient. And so let's just look at that for a minute. So this difference quotient was defined as if I have a function, I'm going to do, for that function, I'm going to evaluate it at x plus h. Then I'm going to subtract from that the function just evaluated at x and divide it all by h. And again, don't get too hung up on this notation. All right, so for a given function, let's take this function. Let's say f of x equals, let's do 3x squared minus 1. Okay, so to do this, my difference quotient is going to be, first let's calculate this part of it. Wherever it means in my function, wherever there's an x, I'm putting x plus h. So I have 3x plus h squared minus 1. All right, so that took care of, that was f of x plus h. Then I'm going to subtract from this f of x, which I already have written down here. And then I'm going to divide this all by h. And the rest is cleanup. So again, was my f of x plus h. This here is my f of x. And of course, this is my h. So I'm just plugging in for this specific function, the pieces of this formula for the difference quotient. All right, and I've got 3 foiling x plus h, x squared plus 2hx plus h squared. Then I've got minus 1 minus 3x squared plus 1 all over h. Let's distribute the 3. So 3x squared plus 6hx plus 3h squared minus 1 minus 3x squared plus 1. Okay, over h. Let's see what goes away. So the 3x squareds, then the negative 1 and the plus 1. So I'm left with 6hx plus 3h squared over h. So if I factor out an h from the numerator, that can cancel with the h from the denominator. So my final, simplified, my difference quotient will be 6x plus 3h. So just kind of a bunch of algebra. And again, this will have much bigger significance when, well, it doesn't have much significance now, but it will have significance in calculus. So I just thought, since we're talking about functions, I thought it was a good opportunity to just do a little manipulation here. And again, you'll see this again in calculus. And that is it for the review.